All right, I know it's a week. I know it's Monday, and I really doubt whether you were thinking about redox reactions over the weekend. Did that happen? Did anybody think about redox? Okay. So what we found out is that another way to classify chemical reactions are not not the way we did in the one chapter, but by their driving forces. And we found out that double replacement reactions, one type, the precipitation reaction. Did you get that right on the quiz? Okay. The formation of a solid. What do you call an insoluble product? They precipitate. Anyway, that's the driving force. And another double replacement reaction, the driving force is the formation of not a liquid, but a very special stable liquid called water. And that's called acid-base neutralization reaction. I know it's a long word, but all right. Then we find out that all the other four, they have the same driving force, and that was one of the extra credits. Driving force is what? Transfer of electrons. And what that means is somebody's going to become more positive and somebody's going to get more negative. And how do you do that? Somebody's going to gain electrons and somebody's going to lose electrons. That's pretty simple. That's what redox is. Redox is somebody's going to get oxidized. Let's read that word again. Leo says GER. If you lose electrons, you got what? Oxidized, or oxidation took place. And if you gain electrons, what?
Reduction.
You got reduced, or reduction took place. Okay, I like that. So anyway, what I did was I was trying to prove to you that a synthesis reaction really was redox. So is everybody with me? Is everybody tuned in yet? Are you out of the weekend? Can I get the? I like weekends, but we're here to do something else during the week. All right, so anyway, let's take a look. How do you assign these oxidation states? Well, if it's an element not combined with any other element, then it has an oxidation state of 0. Sodium is not +1. Sodium is 0. If I just had a piece of sodium, it's 0. But what about sodium in a compound? It's a +1 ion, isn't it? So its oxidation state is +1. Okay, that's pretty simple. Now, what I'm going to do is, the only time, I'll show you these things called reactions. These are called half reactions because they only tell half of the story. So the first half of the story is Leo. So let's see who got Leo'd. I just made it up. Who got Leo? Who got oxidized? Well, here's how you have to twist your brain. Do you remember a long time ago when you're talking about ions, metals like to lose electrons, and your mind kept saying negative, negative, negative? But what happens if you lose electrons? You had to twist your brain, didn't you? That's the same thing here. If you lose negative electrons, if you used to be neutral, and you lost some of your negative electrons, what happens to you? You become more positive. And so think about a number line. Which one of these guys got more positive on the number line? Going from 0 to +1 or 0 to -1? Okay, so sodium got oxidized, didn't it? Now the way I do it, the way I teach the half reaction, and you don't have to like my method, but it works for me, but I do one element at a time. So I have one sodium, so I just think about one at a time. One sodium turned into what? And you look on the other side of the arrow, he turned into a what? What's this called? An ion, didn't he? So one sodium atom turned into a sodium ion, and he turned into something else. What else he turned into? He turned into one electron. And because you go from 0 to +1, you must have gotten rid of one of your negative things. And then what I did is, that's the story of each sodium. Now I go up to the balance equation and say, did you only start with one sodium? You say, no, I started with how many? 2. Well, if one sodium had to lose one electron, then 2 sodiums had to lose 2. And did you only end up with one sodium ion? Let's take a look. No. I had 2, right? And these are the only equations you don't reduce, by the way, because it's only half of the story, so you can't reduce these. Anyway, let's go down to chlorine. Now, I'm going to do chlorine again. This will be a third time. Let's take chlorine. Each chlorine started out with what? Each chlorine started out as 0, didn't it? Now, did you notice on Leo, I put the electrons over here on this side because it's a product? But what happens with GER? Where do the electrons go when I do the GER? Yeah, because they have to be added. This has to combine with this to turn into that, doesn't it? All right, so let's take a look at chlorine. each chlorine started out as 0, leave a space, and each chlorine turned into what? What's that? Okay, chloride ion. How does that happen? How do you go from 0 to -1? How do you do that? You must have gained 1 electron. And you were negative, right? Does that make sense? Now we go back and fix the numbers. Did you really only start with 1 chlorine? No, I started with 2. In what form? It really was a diatomic chlorine. Well, if each chlorine had to gain 1 and you have 2 chlorines, that must be 2. What'd you end up as? 1 chlorine ion? No, look. 2. And everything works, doesn't it? And the most important thing is you cannot have somebody lose 2 electrons unless somebody else is there to do what? These have to be the same. They have to be, don't they? Anyway, that's how you do redox. Now, did we do this one the other day, or was that the other class? Is that the other class? Did you do this one? Okay. You did this one?
Well, we didn't have time to write it down.
Okay, so I'll do it again. Okay? Let's do it again. All right. Let's do one. Wow, a lot of notes. Let's do another one. Can I prove to you that a single replacement reaction is also redox? So let's do this one. Okay. Oops, sorry. All right, so first of all, let's balance it. Can everybody balance this equation? Okay, go through there and let's see if we can balance it. Everybody okay on that? 2. What do you think? You okay on that? Okay, 6. Let's assign oxidation numbers, okay? What do you think? Is everybody with me on this? I can talk, and if you're not listening, if you're not trying to understand it, then it's not. I'm just talking, aren't I? How many people? Be honest. You know how to assign an oxidation number to everybody on here. Raise your hand if you know how to do that. Right? Just one? Okay. So we should be raising our hand, right? So how do you assign oxidation numbers? What's the first rule you learned? If an element is not combined with any other element.
0.
Okay, do you see any of those there? There's one. There's one. That was pretty easy, wasn't it? In an ionic compound, it's whatever the charge of the ion is. What is the charge of the iron ion here?
3.
It is +3. And what's the oxygen? -2. What about here? What's the charge on aluminum? It's just a coincidence. It's just a coincidence +3. And what's this one? Are you okay on that? So step 2, we assign oxidation states to everybody. Now, when we get ready to do the half reactions, let's do Leo, let's do Gur. Just take a look and remember, if you lose negative electrons, you become more positive. Take a look and what element got more positive on the number line?
Aluminum.
Okay, aluminum went from 0 to what?
3.
Yeah, okay, so we're going to put aluminum here, aren't we? And aluminum started out what oxidation state? 0. And because, what did it turn into though? Let's take a look. It turned in, don't do that. We're not doing any numbers yet. We're just going to look at, it turned into aluminum what? How can you do that? How can you go from 0 and jump all the way to +3?
Lose 3 electrons.
That's right. You must have lost 3 negative electrons. Does that tell the story of each aluminum? Well, now we'll go back. Now we'll go back and fix the numbers. How about that? Now we'll go back and fix the numbers. Did you really start with 1 aluminum?
No.
No, start with 2. That's easy. Well, if each aluminum had to lose 3 and you have 2 of them, then we're going to change that to a 6, aren't we? We're almost done. Now, this is where people make mistakes, and I don't want you to. What do you end up with? Just one of these?
2.
2. In what form? Be careful. Be careful what you say here. I know what your eyes see, but what is this actually made of? It starts with I.
2 aluminum ions.
Ions. It's made of what? 2 aluminum ions and what? 3 oxygen. Okay, so I do not write Al subscript 2. Why? There is no diatomic aluminum. It's not in that form anyway. Now, are you okay so far? And remember, half reactions we don't reduce those. Yes.
Why did you do like diatomic like chlorine last time?
Okay, because it really was diatomic. Let me see if I can find it.
Oh yeah, that's right.
On this one, it really was diatomic chlorine. See that?
Yeah.
Okay, now, all right, let's do GR. Now, be careful here. If you gain negative electrons, you become more negative. So who became more negative here? See if you can find it. Iron? He went from +3, what? Whoop. He dropped all the way down, didn't he? So I know the iron starts as +3. We're going to leave a space here because GR, we're going to have to do some electrons on the left side. And what did he turn into? He turned into iron 0. How do you do that? How do you go from +3 and tumble all the way down to 0? By gaining what? 3 electrons. Does that make sense? Now we can go back and fix the numbers. Each iron did that. I get it. Did you only start with one of those?
No.
Now, do not put a subscript 2 here. There's no diatomic iron there. You get that? There is no that's iron oxide, isn't it?
Yep.
So how many? We had 2 iron ions. And if each iron ion had to gain 3, then it must have gained a total of 6. Now let's go over here. What form did it end up as? Let's take a look. Hey, just iron. And there were 2 of them, right? And now, the thing you always check is these have to be equal, don't they? And by the way, in redox, it's not like you lose electrons and then 5 seconds later somebody gains it. It has to happen at the same time. That's what redox is all about. All right, what do you think about that? These are called half reactions. Now, that's not in your book, actually. This part is the one part's not in your book. I've been trying to get you to, I understand, like for example, I understand why you don't want to necessarily read some of the chapters. Like for example, how many pages did the author take to show you about that solubility chart? And here's some beakers, here's some beakers, here's some beakers, here's some okay, I get it. But he's just trying to give you example after example of what's going on. Okay, so I understand that, but there's no reason why you can't be scanning the chapter and when you go down here and see a dark print word, what's that? What's that? Oh yeah, I remember that. And you keep going, and keep going. All right, so what I'm gonna do here is, we're gonna read one more article. What time is it?
Oh.
Okay, we have 10:40. Wait, 10:40. Oh, you gotta go.
Oh! Oh no!
All right, goodbye. Hey, thank you.
Alright, thank you.
I'll get your quiz back in tomorrow, and we'll do one more. We'll do one more of those. If you want me to do one more of those, I'll do that, and then we'll talk about energy changes, and that'll be it.
Hey, no! Hey, give it back, Freddie. Drop it, sir. Stop taking a picture because you didn't make your own Quizlet or page. You're never gonna get it. Why didn't you just make your own? I have flashcards, but they're not. Then just use your flashcards. Use your flashcards. Why don't you just use your flashcards? New process of law is not on there. Okay. Is it?
I guess not.
No, is it?
I know.
Thank you.
All right.
Can I show you, ask you something on the quiz?
Yeah.
Is alcohol a electrolyte?
Okay, now that's a good question. What's alcohol made of? It's made of carbon, hydrogen, and oxygen.
Yeah.
So what kind of bonds would hold non-metals together?
Covalent.
Right, so that's not made of ions to begin with, so if you dissolve in water, it's not gonna break up into ions, so it'd be a non-electrolyte.
Oh, okay.
That's all right. You had a chance to get bonus points anyway, didn't you?
Yeah.
I bet you got some of those. So, you can miss 2 points there, get 2 points, 4 points.
Oh, and then what was the net? I think I blanked on the net ion equation. Like I got
The net, okay.
like this. So I crossed out the 2 nitrates because there was 2 over there,
That's true.
and then I crossed out the barium because there's 1 over there.
Well, what's weird is, unfortunately, silver is +1 and chlorine's -1, so I'm not sure why you put a 2 there. And then also, I don't see any ions. And if the net, wouldn't you think the net ionic equation might have some ions in it? And then all of a sudden, I see this, then I see this, and I'm not sure what the heck's going on there. How about this? The silver ions, they're dissolved in water, combined with, how many do you have? 2? 2 silver ions combined with what?
2 chlorine.
See? And they formed 2 AgCls. So I'm not sure where that's coming from. This.
This I didn't even have there. Like that.
Yeah, but think about this. You actually wrote silver chloride 3 different ways. Isn't that weird? But anyway, so this one you're gonna miss all of those points.
Okay.
But anyway, you have a chance to get some bonus points. Let's take a look up here. You're good up here. Look at this. You're good at this. You're good at this.
What's
Okay.
the -1 for?
Well, because it's worth 3, but you have no ions. See, ions have charges, don't they?
Yeah, but
They have no ions. So I took off 1 out of the 3, but because that's why you also didn't have them down here either. If you'd had this here, you just drop that right down there. See, what's interesting is you had this, and yet you
well,
didn't.
no, that should just be crossed out because I put that and then I.
But even that, what about that? What's
Yeah,
that?
it
So, all right. Here, go put it back. I'll get it for you.
How much is the donut?
1 apiece.
So I'm gonna be